Good morning, welcome back to my Bit Code. This will be day 12. I didn't manage to solve part 2 yesterday, but somebody on Reddit pointed out that instead of storing each number as the number modulo the product of all your divisors, you can store 8 copies of the number, each one modulo one divisor. And when you need to multiply by 3, you multiply each one by 3 and then take it modulo that divisor. And then you don't need to do big ints at all. And I think this would bring the runtime of my part 2 to about an hour, something like that. So maybe if today's problem is quick, we could have a look at part 2 of yesterday's problem. The other thing I've done is I've now actually done some measurements of the speed of integer operations on SCAMP. And I've got a table here. Anyway, so it's time for the problem. Good luck, everyone. Hill climbing algorithm. Okay, it's a 2D grid. "31 steps for the sample problem. Is that 83 by 83? No, it's not square. 83 by 40? Don't know. 3444 divided by 41. 83 by 41. Okay. Usually they're square, which is... Anyway. Got a height map of the surrounding area. "26 elevation levels. As few steps as possible. You can jump down, but you can only step up by 1. Okay, so on the sample input we have to spiral around. Okay, silent contemplation time. Well, it's just choice path, isn't it? I'm trying to remember how I normally do a queue. Oh, how have I done this before? I must have done this loads of times. I remember I wrote a heap implementation for a priority queue. Maybe I just use that. So, we want to have I keep meaning to write a reference for all the slang functions so I can remember how to use stuff like this. So what? Is that the best way to do it? I'm working out how I'm going to represent everything first, and then I'll bother with reading the input. So P is pop from the Q. I might have to just read how the heap works. Oh, we need to give it a comparator function. Maybe we don't bother with the heap. Okay, I know what we're going to do. We're not going to bother with the heap. We're just going to make the Q a graph and we're never going to free any memory. QIDX is where we're reading from. When we append something, we just push the X and then push the Y. So we don't need this. Okay. Fine, now we can read the grid. Now we need to find the start position. Well, it's X, isn't it? Okay. So we also need to push the path length. So if a neighbouring cell is less than or equal to the current cell height, and we haven't visited it already, let's visit it. Equals E, then we're finished. Out of memory. Oh no, okay, fine. Okay, hasn't worked. Oh, I forgot to. Oh no, I did increment Y. Wonder if it's quicker to compile it or to comment out the bitmap code. I forgot to set it again. So this should print out the input and then crash. It crashes before printing out the input. Oh, because we're actually calling BM new, aren't we? Would have been quicker to compile it. Empty. What does the line look like before we blank off the end? Also forgot to check whether the neighbouring cells are within the bounds. And forgot to increase I. But what's going on here? So we print grid Y, we work out its length, we blank off the end, and we print grid Y and it's the empty string. Oh, because Y++. Silly. Okay. Let's print F. Let's. Okay. We want this back. We want these gone. We want this gone. We want to implement this. Okay, it printed no solution, but I forgot to put the second argument to printf for no solution. So why is there no solution? Because the first letter is capital, which means the others are all much higher. Also need to mark the first square as visited. What does it say? What does it say the height of the starting square is? Maybe everything's fine if the starting square is... Maybe every Every adjacent square is fine. So if yx equals s, all that. I think the answer is going to be off by 1 as well. Because imagine if E was directly adjacent to S, it would print 0 instead of 1. So if it says 30 now, I'll just run it on the real input. Okay, it doesn't. 24, incorrect. Oh. I think I might be correct. Ah. When it gets to the tile immediately below the E, it goes straight up. So, does it actually specify? S has elevation A and E has elevation Z. Okay, fine. So, I missed that the first time. That's bad. Should have read more thoroughly. Still wrong? Oh, because... stupid. Making a bit of a meal of this today. And having to run the compiler means not iterating nearly as fast as I have been on previous days. Cool, now we play the waiting game. How much slower is that likely to be? 100 times slower? If it's about 10 times as far in both directions? Or worse than that? Not sure. Excellent. It says there are more choices for starting position. Answer's 29. As you walk up the hill, you suspect the elves will want to turn this into a hiking trail. The beginning isn't very scenic though, perhaps you can find a better starting point. To maximise exercise, the trail should start as low as possible, elevation A. The goal is still the square marked E. However, the trail should still be direct, taking the fewest steps to reach its goal. So you'll need to find the shortest path from any square at elevation A to the square marked E. Again, consider the example from above. Okay, so we have a set of starting squares and we just run shortest path from each one, maybe? If we've got room for a second grid, then we can cache computed path lengths. Not very easily. Oh, we want to start at the E. We want to start at the E, explore the entire grid, and store the length of the shortest path to any A. Good problem. So now, if it begins with an E, then that's where we start. If it has an S, we simply treat it like A. We no longer have an end. And in fact, just to make doubly sure, I will delete it. Starting square is a Z. We're now allowed to go we used to be able to drop down. We're now able to go up as far as we like, but we can only drop down by 1. If grid ny and x equals A, then best len equals -1, or len is less than best len, len equals len. From the best len. Now let's give it some thought. I think that might be okay. We can bail out early if we ever have a path that is longer than best len, because we know we're not going to find an A that's shorter. In fact, I think that's going to be worth doing. So it's just the first A we get to, isn't it? Maybe I should include the bitmap code in the library blob in the interpreter, and then I can do problems like this using the interpreter. I could also make a queue implementation which works exactly like a GRAR, except whenever it has to realloc, it knows that it doesn't need to keep the stuff that's already been popped out of the queue. I'll do that. Great success. How are we looking? Oh, Extrabot hasn't done part 2 yet. Oh. It's only been 40 minutes. Maybe we'll have a look at part 2 of yesterday's problem. Okay. How far did we get? I think I copied part 1 to part 2 but didn't change it, but just in case. In fact, I'm sure I didn't change it. So what we wanted to do is, for each number, we don't need them to be big ints. So let's get rid of all the big int stuff. But we do need special monkey numbers. I call them monkey ints. And these are simply the number modulo that monkey's divisor. We need to... Okay. Okay. Where do we get the number of monkeys? Right, we'll do all that and then we'll do monkey ints after. New monkey int. Pi is x modulo the divisor for that monkey. Now, this has to be monkey mul, monkey add, monkey mul, whoops. Is that a text editor bug? Monkey add. Monkey add. Monkey square. Monkey add. Monkey add. So what we want to do is replace each number of each monkey with the corresponding monkey int. I've already got an I at the global scope. No. Do I have to make one later? Yes. Ugh. Globals, am I right? How do we end levels? We no longer do the division by 3. And the test for divisibility is now simply a test for 0 under that monkey's so if old M equals 0. I don't like the word old. What are we going to call it? It's a monkey int. Let's call it num. Okay, this will want to be 10,000. In fact, if we're going to compile it, we'll make that an argument. Oh, but we already have an argument for sample input. But we can't have sample and num rounds the other way around. Actually, we can. This is a waste of time. I could just remember the order. Okay, fine, good. We can pass the number of rounds. Have I finished? Let's try it. Do I even need the compiler? Can I just run it in the interpreter? Can't remember what the sample answer was yesterday. 433 times 421. Block needs closing brace. Oh, else. If is digit. Just before we do the rounds. Right. It won't get the right answer for the sample input because it's not doing the division by 3 anymore. But the division by 3 is non-trivial. Every monkey has done 100 passes. Or the top 2 monkeys have done 100 passes. Is that what we'd expect or not? Oh, I haven't written the monkey int functions. Oh my god, oh my word, it's bad. And the sample input is still used. Well, so M is a monkey int. is the argument. So to multiply a monkey int by x, oh no, n monkeys is already declared up here somewhere. Okay, fine. Well, I left in monkeys. Mi equals mod mul mix individual I. And to square a monkey number, multiply it by itself. And since the highest modulus is 19, it will not be a problem. Sadly, I think we're going to have to run 10,000 rounds even to work out if we're handling the sample correctly. Looks like we did about 2 rounds a second. Obviously with the real input that would be slower. Okay, well it's at least doing a different number for each monkey. If we do 2 rounds a second, it will take 5,000 seconds to do the full lot, which is over an hour. So what I might do, I wonder if there's sample output. Oh, I know what to do. We'll make part 2 bad. Just not do the division by 3. Right? Then we're laughing. Can we see anything wrong in here? Maybe if we just do a few rounds. Okay, so it gives us, it tells us 103 times 99 is the correct answer after round 20. Okay, that's useful to know. So it's the monkey version that's wrong. But why? Wow, it gives us the answer after round 1 as well, so we can just do that. It should be 6 times 4. 7 times 4. Maybe it just is counting a single 1 extra for monkey 3. Maybe the counts are uninitialized. What I'm going to do before I forget is copy today's source over the serial link, so that if I end up running a several hour day 11 program, I've already got it. And then let's try to work out why we're counting 1 extra pass for monkey 3. Oh, 1 extra inspection, sorry. Inspections. It is zmalloc. wonder if the squaring function is actually sound. I think it is. Well, since the count is only one high after one round and still only one high after 20 rounds, it seems like every round except the first round works correctly. But for some reason, we're doing an extra inspection for one monkey. I think it's 6-4-3-2 after one round. I can't remember what it is after 20. Okay, so that's correct. What? Wasn't it saying 7 before? Did I change anything? That's bad. Either I changed something that I thought was not important, but it was important, or the CPU has been not working correctly, or the program is non-deterministic. Alright, it's getting the right answer now. This bothers me. That's all I think I changed. Don't recall changing anything else. What? How bizarre. That's very, very strange. Before I commit to running this for several hours, I'm just going to do some checking to make sure it's reliable. And I also want to see if the behavior is the same after it's compiled, or whether it might be an interpreter bug. Very strange interpreter bug. Yeah, okay, so that seems to work the same every time, and that gives the correct answer. And does this one work the same every time and still give the incorrect answer? Well, at least it appears to act deterministically. Let's see if the compiled version is also wrong. I'm not using big int, am I? Maybe that is a pointer to the problem. Oh my word. Why does that get the right answer then? Maybe with random numbers. Okay, that explains why it gets right. That explains why the answer is different. The problem was the numbers that we were starting out with were essentially random because they were pointers. But when there's more code, the pointer addresses are different. And it just happened that they lined up correctly with the number of operations lined up correctly. Wow, okay. Let's try that then. So that should now give us the correct answer. It's really good. So we can compile it, we can check on one round 20 rounds, then set it running for 10,000. Am I still using Big New? What the hell? What line number did it say? Okay. Maybe I want Kilo to have non-incremental search because the search is so slow. So instead of having to slowly press a character at a time as it searches what I've typed so far, I should just type my whole search term and then let it go. Six times 4, good. It's nice and fast as well. Good. In that case, 10,000 rounds, please. It's about 2 seconds per round, so that's going to be 20,000 seconds. It's going to be 6 hours. Not to worry, I can simply leave it running all day. So, speak to you later. It's been about 5.5 hours, and we're almost finished. Do we reckon it'll have the right answer though? Suspicious power of 2. Day 11, part 2. Ah, bad.